So whilst we're talking about quadratics, it makes sense to talk about completing the square. This does factorise, of course it does, but I'm using this as an example because we can see the answers. So yeah, x squared plus 6x minus 7 equals 0, the idea of completing the square. You see, that's not a perfect square. We would like to make it a perfect square, so we'd like to complete the square. So what do? Well, we move the constant. Constant goes to the other side, that's 7. Then we add half the coefficient of x squared. Now that pause is important, of course, because it's not half the coefficient of x squared, it's half the coefficient of x squared. So the coefficient of x is 6, half of that is 3, 3 squared is what we're adding to both sides. On the left hand side, now we have a perfect square. We have completed the square. So we factorise it, x plus 3 all squared. If something squared equals a number, we know it's plus or minus its square root. So plus or minus 4. I can move the 3 over, becomes negative 3, and there's my two answers. Negative 3 plus 4, negative 3 minus 4. That is the idea of completing the square, and is in fact where the quadratic formula comes from. Let's generalise the quadratic. Ax squared plus bx plus c equals 0. Now, we like monics when we're completing the square. So the first thing I'm going to do here is divide everything by a. And now I've got a monic. Move the constant. So minus c over a goes to the other side. Add half the coefficient of x squared. Well, the coefficient of x is b on a, so half of that would be b on 2a. Going to add that squared. The left-hand side is now a perfect square. The right-hand side, well, we can do better than that. It's an algebraic fraction. Let's join it together. Ooh, look at that. B squared minus 4ac, there's that bit, but it's over 4a squared. Square root of both sides. We get x plus b on 2a is plus or minus the square root of b squared minus 4ac on 2a. Move the b over, and there's the quadratic formula. That's where, of course, it comes from. And that's what we do in maths. We find a pattern, and that creates a formula, which means we don't have to go through that process every single time. We can just go straight to the formula. But here's another way of completing the square. It's a little bit different. I've got x squared minus 6x plus 6 equals 0. Instead of moving the 6 to the other side, I go, well look, I want to complete the square on this, and I know it should be x minus 3 squared, because that would create the minus 6x, but that's not going to give me 6. That's going to give me 9. So I make it minus 3. Now why do it like that? Because now what we've got is the difference of two squares. 3 is the square root of 3 squared, which factorises to be x minus 3 plus root 3, x minus 3 minus root 3. Therefore, x is 3 minus root 3, or x is 3 plus root 3. You see, every quadratic could be rewritten as the difference of two squares. Well, once we know about imaginary numbers anyway. Okay, yeah, that's down the track, but everyone can be done that way. Okay, so 1h we now will add.